I'm Will St. Clair. I'm a solutions architect with AWS covering Columbia University, NYU, as well as some other universities in the New York area and Connecticut. I'm your technical contact for AWS. So if you're doing research that's using AWS, if you are doing, you don't have any questions, feel free to reach out to me. I'm part of your account team here on campus, so I'm more than happy to help you out. Thank you for the invite. I was asked to just come and give a quick introduction to scientific computing on AWS. I don't have a ton of material. I just wanted to give you guys an overview. Who here has used AWS before for your research? Excellent. We have a lot of customers doing research on AWS, so I wanted to just go through some of the use cases really quickly, some of the products that are most salient, and some of the reasons that you might choose to use AWS for your research workloads. So if you look at the services that make up AWS, you can think of it as sort of a stack from bottom to top. At the very bottom is our global infrastructure, things like our regions, which is our physical data center presence worldwide, our availability zones within those, as well as our global network of nodes for content delivery, as well as DNS. On top of that is what we're probably going to focus on today, which is our foundational services for compute and storage, as well as some of our higher-level platform services. These are things like our managed Hadoop service, Elastic MapReduce, our managed container service, Elastic Container Service, and additional applications that may be of interest to you guys. Globally, we have 11 regions. Each region you can think of as a full self-contained cloud. Data does not move from one region to another unless you explicitly move it. So this is, especially if you're dealing with sensitive research data, for compliance or data locality reasons, when you place data into an AWS region, you can be confident that that data does not leave that region. Within each of those reasons, we have what are called availability zones. You can think of an availability zone as a completely isolated logical segment within a region protected from failure, such that two availability zones don't have shared systems in terms of electricity, in terms of HVAC, et cetera. We also have 53 edge locations worldwide, and this is just to accelerate things like caching and DNS at our edge locations. Government agencies and educational institutions worldwide are using AWS. We have customers all across the federal space, the state and local space, as well as educational institutions worldwide. To get on the specifics in AWS for scientific computing, I wanted to talk about some of the reasons that researchers may choose to use AWS. A lot of research groups have large clusters on premises that they may already be using. And in a lot of cases, a lot of researchers opt for a hybrid model where they use the resources they have on-prem in conjunction with resources in AWS because they want to enable collaboration. Or they might want to go directly to AWS because of constraints on the resources they have on campus. So the main reasons are accelerated time to science. If you are dealing with an oversubscribed cluster on campus and you need to get it done now, AWS lets you pay for the compute capacity that you need when you need it. Lower costs. By bidding on capacity through our spot market, you can pay far, far below the market rate for a given piece of hardware. You spin it up like you would a normal EC2 instance, and you even get a 2-minute warning if that instance is preempted due to being outbid. So we see customers, especially in the research space, using spot instances to really stretch their budgets in terms of the compute that they can get done. It's globally accessible. So a lot of customers have research workloads where they need to collaborate with institutions, maybe not just the United States, but worldwide, that AWS allows them to put their data sets on a shared resource like Amazon S3, our storage service, and then researchers can bring the compute to the data as they need it by spinning up resources on EC2. We're flexible. We have instance types with small amounts of RAM and large amounts of compute. We have instance types with large amounts of RAM relative to the amount of compute. And currently we have GPU instances, and coming next year we have what we call X1 instances. These are instances with over a terabyte of RAM and over 100 virtual CPU cores. This is especially interesting for customers working on genomics workloads. It's elastic and scalable. So if you have a compute cluster, you can spin one up. You can grow that cluster as large as you need for the duration of your job, and then you can scale it back down when you're done and only pay for the compute you're using. And it's secure. We have customers running sensitive workloads all the way from healthcare to finance, federal government, et cetera, on AWS. So just talking about some of the time to science reasons, one of the great reasons customers choose AWS is to get the agility. If you have an on-premise resource, it's difficult to keep that at optimal capacity. Either at any given time it tends to be undersubscribed or oversubscribed. With AWS, each research group can have their own account. They can get the resources they need to run a particular job and shut those resources down when they no longer need it. So this allows you to not only run multiple jobs in parallel if you need, have a busy time, but also to keep that in balance with the actual work that you need done. And you can reduce your costs by going with different pricing models. If you have a very steady state workload that cannot be preempted, we have what are called reserved instances right there in the middle. That allows you to prepay for a given instance. Or if you just need to get a lot of compute done on the cheap, you can use spot instances to bid on unused capacity. For collaboration and global resource, we see a lot of customers doing this, especially when dealing with GIS or mapping workloads. They'll put all of the shared data in an Amazon S3 bucket. You can expose that data using things like cross-account permissions and request or pays buckets to charge back the download costs if they're accessing it outside the region. And those customers can bring the compute to it, run the computation they need, put that data back in a bucket for other researchers to use as needed. In terms of compute services, the flexibility, we have very large instance types and we have very small instance types. We also additionally have the ability to place those instances in what we call placement groups. Placement groups give you full bisection 10 gigabit bandwidth if you need to bring up a large compute cluster for a very heavy high performance workload. We can use GPU instances to run your whether you're CUDA applications or whether you're running graphics applications. Those are popular as well. And you can use auto scaling. That allows you to, say, put a bunch of jobs in a queue, spin up the cluster as large as you need to get them done, and then that cluster scales back down when you're done. As far as security, we have customers running very sensitive workloads in AWS. We have an authority to operate from Health and Human Services for FedRAMP. We have the ability to enter into a BAA for HIPAA compliance. We have customers running educational workloads, obviously. If you are working on something export controlled, we have the GovCloud region, which allows you ITAR compliance. So, depending on the workload, feel free to reach out to me or anyone else at AWS, and we can help you, figure out how to architect that for security. Additionally, we have auditing and access log resources that allow you to get information about activity performed in your account. With AWS, as with any other vendor, security is a shared responsibility. We take care of what we call the compliance of the cloud, the security of the facilities ourselves, the security of the software you write, but the responsibility is shared with the customer in terms of configuring those resources correctly, and we're here to help you with that. And the other cool thing is that the economies of scale apply to security and compliance as well. We have customers with very demanding security requirements, those in education, the financial industry, healthcare, and those customer requirements, rather than us trying to just carve off individual segments of our network for them, they just allow us to raise the compliance bar across the whole network. So any customer is using the same platform that's being used for sensitive, high security requirement workloads. So next steps to get started on AWS as a researcher. If you're interested in high performance computing, I'd highly recommend you check out our CFN cluster. This is basically a CloudFormation template. This allows you to spin up a set of resources in your account based on a template. You can check out the link there on GitHub. And this is sort of a baseline for setting up a high-performance computing cluster. It allows you to upload a script that'll get run on a set of instances, includes a queue for you to schedule jobs, and you can run software, additional software on top of that, schedulers, runtimes like R, file systems like Gluster, et cetera. And also we have several research and scientific initiatives for AWS, whether those are grants, if you're interested in perhaps collaborating using special AWS functionality, sharing with the community at large. We'd especially like to hear from you, as well as our public data sets. And we have a dedicated scientific computing team that I can put you in touch with if you have a very specialized need. And thank you. Like I said before, I'm the solutions architect here at Columbia, so I'm here to help you, the researchers. Shoot me an email, and I'll be around for a little bit afterward to answer your questions. Thank you.